Good evening everybody and welcome to Creatrix channel, my dear friends. The channel which is creating history, which is creating revolution in the field of GATE and ESE education and providing the most quality education day in day out from morning to evening with the best educators across the country coming live to you every day from morning 7 a.m. to evening 11 p.m. Everybody is teaching live and providing you the most awesome concepts, and that too only for that too free of cost on this channel. So I welcome you all to the new session on control system, that is the stability using polar plot and the Nyquist plot. So my dear friends, what we have covered till now, we have covered how to draw the Nyquist plot, okay, how to draw the Nyquist plot, as well as we have seen how to draw the polar plot. We have seen the Nyquist stability criteria, and today what we are going to learn is how to judge stability both using the polar plot and the Nyquist plot, as well as I have some interesting examples for Nyquist plot. So now my dear friends, let me first introduce myself for those of you who are not aware about me. My friends, my name is Ankit Goyal. I got AIR 1 in GATE 2014 and 2018 Electrical Engineering, and I was awarded the President of India Gold Medal by the President himself. And I have taught more than 1 lakh students both online and offline, and presently I am working as a director at Unacademy for GATE department. But that is not the reason why I am here in front of you. The main reason why I am here in front of you is because of the revolution that we have created, the surge that we have created among the students of electrical and the electronics engineering, and my responsibility towards you, towards your preparation, towards your rank, that compels me to come here every day and add fuel to the fire, add fuel to the revolution that we have started and keep it going on. But my friend, revolution does not work directly through me. It has to work through you. You guys are the soldiers of this revolution, and you have to spread the revolution as far as possible. For that, you just have to do two things. First is like the video to mark your attendance. Second is to share the link of the session in every group possible, Telegram, WhatsApp, Facebook, everywhere you have to spread the link like wildfire. Now my dear friends, one thing that I would like you all to do is download the Unacademy learning app, because that will give you a competitive edge over other aspirants. And my friend, if you want to watch the most awesome videos that I have personally created on Unacademy learning app, then you can visit this link. tinyurl.com/AnkitESE. Here I have kept all my videos that I have taught till now, and you can just go and watch all the videos like MOSFET analysis, like transient steady state, transfer function, power system protection, everything is there. Just click on the link and start studying, start reading the content. Okay. Now, my friend, if you want to become a part of our batches, then you have to join Unacademy subscription using the code AnkitESE, because that code not only gives you 10% discount, but it also directly brings you under my guidance so that you can prepare in the best manner possible and crack GATE with the highest rank. Okay. So do remember this code AnkitESE. Now, what is Unacademy subscription all about? Unacademy subscription, Unacademy Plus contains live classes, test series, weekly quizzes, daily practice paper. Other than that, my friend, crash courses, rank improvement batches, everything is there. So you get unlimited practice. You can practice in the session of any educator, be it me, be it Vishal sir, Kamesh sir, Sankar sir, anybody's class you can watch. So the door to Unacademy once open, you are available, everything is available to you. You can watch any educator that you like. So unlimited practice, test series, schedule is structured. The schedule is in the form of batches. And my friend, you can attend the live classes, and we provide daily practice paper for practicing. And mark my words, the quality of DPP is much better than the previous year GATE questions. So that means if you solve the DPP, you will be able to crack every previous year problem. But my friend, Unacademy subscription has just gone iconic. What is iconic subscription? You get personal coach who will guide you day in day out regarding the preparation, study planner to manage your time, expert guidelines, and my friend, ESE mains question and answer practice. That means now, my dear friends, you will be able to write the answers in the best manner possible in ESE, so that you can get the best rank not only in GATE but also in ESE. So Iconic subscription can put you from a below average student to one of the toppers, because my friend, what does a student from a private college needs? He needs just a little bit of guidance, just a little bit of support, and I believe he has the potential to compete with the students from IITs and NITs. So they just need a little bit of guidance, and that guidance will be provided by this personal coach. So if you want to avail this, you have to go for Iconic, because Iconic will get you a truly iconic rank in GATE and ESE. Okay. Okay then, my friend. Is that clear? So let us start. Today what I am going to discuss is how can you judge stability using the polar plot. So first of all, let me tell you one thing. That it is only applicable for minimum phase system. Okay, minimum phase system means which does not have a pole or zero in the right half plane. So this concept of stability using the polar plot is only applicable for the minimum phase system. And my friend, how to do it? Check enclosement. Check enclosement of -1, 0 point by polar plot. So listen to me carefully. GSHS does not have any pole or zero in right half plane. So that is minimum phase. Now, if -1, 0 is enclosed, closed loop system is unstable. Okay. And if -1, 0 is not enclosed, closed loop system is stable. As simple as that. You just have to check whether this -1, 0 will get enclosed by the polar plot, or it does not get enclosed by the polar plot. My friend, today on my screen I can see the number of viewers are more than number of likes, and that is not at all allowed in my class. So that is why you need to like the video. You need to hit the like button to mark your attendance, so that I can know how many people actually attended the session. Now, suppose I give you an example. This is the real part, imaginary part. Now see carefully. Suppose we have a plot like this. -1 point is lying here. -1 is lying here. So now, my friend, what did I tell you? About enclosement? I told you, if you are walking along the polar plot and a point lies to your right hand side, it is said to be enclosed. So suppose now we have Garima walking like this. Okay, Garima walking like this. Now tell me, whether -1 will lie on the right hand side or not. Yes, it will lie on the right hand side, my dear. It will lie on the right hand side. If it lies on the right hand side, you can say closed loop system is unstable. Very simple, very simple. Okay. But my friend, remember, this is only applicable if GSHS is minimum phase. Okay, it is only applicable if GSHS is minimum phase. Is that clear? Is that clear, this stability criteria? The advantage of the Nyquist stability criteria is it is applicable for minimum as well as non-minimum phase. Minimum as well as non-minimum phase, and for your polar plot, it is only applicable for your minimum phase. For your minimum phase. Anshu, I am saying it is only applicable for minimum phase. By minimum phase, it means that the open loop system is by default stable because it does not have any pole or zero in the right half. So we are not checking the enclosement of origin. We are just checking the enclosement of -1, 0 point. Gajendra, yes, we can draw polar plot for non-minimum phase. If you remember yesterday itself, we drawn the polar plot for the all pass system. I drew that, and the Nyquist plot was a circle, but the polar plot was a semicircle. So yes, we can draw polar plot for a non-minimum phase system, but we cannot judge its stability using polar plot. Okay. So what I am saying is, polar plot exists for non-minimum phase system but stability cannot be determined. Is that clear? Polar plot does exist, but we cannot determine the stability. Now let us quickly revise the stability criteria for Nyquist plot. It is applicable for all types of system. Just like Routh, na? Routh is also a universal criteria. Nyquist plot is also a universal criteria. Okay. That is, it is applicable for minimum phase and non-minimum phase. It is applicable for all type of system. Now, there are two criteria if you remember. Criteria number one is N is number of encirclement. Number of encirclement of 0, 0 point. 0, 0 point. So here N is greater than 0 for anti-clockwise encirclement and N is less than 0 for clockwise encirclement. P is number of open loop poles in RHP, and my friend Z is number of open loop zeros in RHP. Number of open loop zeros in RHP. Okay. Now criteria number 2. Criteria number 2. n is number of encirclement of -1, 0 point. Again, n is positive for anti-clockwise encirclement and negative for clockwise encirclement. The definition of P remains same, number of open loop poles in RHP, but the definition of Z is now number of closed loop poles in RHP. Both the plot are for GSHS only, but by means of origin you are checking the stability of open loop system, and by means of -1, 0, -1, 0 you are checking the stability of the closed loop type of system. And my dear, for open loop stability, P is equal to 0, and for closed loop stability, Z is equal to 0 in second case. Okay, so you can judge the stability of both open loop and the closed loop system just by looking at the Nyquist plot of the GSHS transfer function. Now Surendra is asking, can pole and zero lie at the same point? Yes, my dear friend, that can happen, and that is called as the pole zero cancellation. Gajendra, no my friend, these plots are not valid for unity feedback because we are plotting for GSHS. Not GS. When we are plotting for GSHS, by default we are assuming the non-unity feedback. Okay, now as I told you, for closed loop stability, okay, see, there can be various cases that can be made here. Case 1. Case 1 is n greater than 0, anti-clockwise encirclement of -1, 0 point, n greater than 0. If n is greater than 0 and -1, 0 point is encircled in anti-clockwise direction, that means for closed loop stability, number of open loop pole in RHP is equal to number of encirclement. Is that clear? Because my dear, if you keep Z equal to 0, n will come out equal to P. If n is come out equal to P, that means the open loop poles that are in the right half plane, that is actually equal to the number of encirclement of -1, 0 point. -1, 0 point. Now, case 2. I am telling you the various cases that you may encounter here. N equal to 0. That is no encirclement of -1, 0 point. Then my dear, that is closed loop system is stable if P equal to 0 or no open loop pole in RHP or open loop system is stable. Got this? What I am saying is, in case n equal to 0, then closed loop system will be stable provided open loop system is also stable. The closed loop system will be stable provided the open loop system is also stable. Case 3, n less than 0. Clockwise encirclement of -1, 0 point. So in this case, my dear, Z will be greater than P and your closed loop system is guaranteed to be unstable. In case -1, 0 point is encircled in the clockwise direction, it is for sure that your closed loop system will be unstable. Closed loop system will be unstable. Vibhud, I have drawn only one type of polar plot for type 1 order 3 system. The only difference in the two polar plot is their real part. So based on the transfer function, you will have to check the real part at omega equal to 0 so that you get to know where that curve is starting. You might have seen one curve is totally near to the imaginary axis, which means its real part is 0. One is away from the imaginary axis, for whom I also derived the asymptote. So that way you have to check the real part at omega tending to 0, and once you have the value of the real part, you can judge whether it is away from the imaginary or whether it is near to the imaginary axis. Okay. So up to here it is clear. Now let me show you some very selected and interesting problems for all of you. I have selected some very good problems that you are going to absolutely love and you are going to solve them in seconds now. Okay. विबुध मेरे भाई, मैंने ये बोला आपको रियल पार्ट चेक करना पड़ेगा टाइप 1 ऑर्डर 3 सिस्टम का ओमेगा टेंडिंग टू 0 पे, ताकि आप ये पता लगा पाओ कि उसकी शुरुआत कहां से हो रही है. आप जो दो कर्व की बात कर रहे हैं, आप बात कर रहे हैं ये दो कर्व्स की. एक कर्व ऐसा था, है ना, और दूसरा कर्व मैं बता दूं. द डाउट फ्रॉम विबुध इज वेरी जेन्युइन. सेकेंड कर्व आई ड्रू लाइक दिस. So my dear, the only difference is in the real part at omega tending to 0, this real part. So for this what you have to do, basically gj omega hj omega, you have to break it into the real and the imaginary part, and once you break it into real and imaginary, you will find its value at omega tending to 0. Find real part at omega tending to 0, find imaginary part omega tending to 0. You will get the location of this point. If the real part comes 0, it is the case. If real part comes non-zero, the first one is the case. Okay? Now let's move on. Here is the first question, everybody. Apply the polar plot. Apply the stability criteria of the polar plot, my dear friends. And you have 60 seconds to do it. Okay, you have 60 seconds to do it. Find out the stability using the polar plot. This is a previous year GATE Electrical Engineering question, and it uses the concept that I have just now taught you. And my dear, I still don't see that you have hit the like button. Everybody, do it right away. Do it right away. Please hit the like button to mark your attendance. Okay, come on everybody. It can be MSQ. It can be MSQ, my dear. Don't just check one option, check all options. This is a MSQ type of question. Okay. And the time is running, my dear. Time is running. Come on, guys. And the time is up. So first of all, remember this is a MSQ type of question. See, in this case, this point -1 is lying to the left. It is lying to the left. So stable. Now suppose this is Ayushi. She is walking like this. Now, this -1 point is lying to the left or the right. Where does it lie? It lies to the right. It lies to the, 1 minute. If I am walking like this, it lies to the left. So again, it is stable. Right? It is also stable. See here. Now if we walk like this, at this point lies to the right. So this is unstable. Similarly here, it lies to the right. So unstable. So the answer to this question will be 1 and 2. Answer to this is 1 and 2. Is that clear? Now, one person Pulkit is asking me कि अगर जीरो और पोल दोनों होगा तो जल्दी से कैसे बना पाए? First of all, dear, if poles and zeros both are there, then my dear friend, you have to plot the polar plot first, and that will need a little time. Okay, that is a little time consuming. But after polar plot, Nyquist plot is very simple. I gave you a shortcut in the last lecture. Polar plot plus inverse polar plus number of infinite semicircle equal to the type of the system. But remember that shortcut was for minimum phase system. For minimum phase. Okay. Now try the next one. Again, this is a previous year problem from ECE it is. Now you get 90 seconds. Now you get 90 seconds. Garima, if -1 point lies to your left hand side, it represents a stable system. Okay. Karthik is saying if open loop system is unstable, can the closed loop be stable? Yes, Karthik, it can be stable. Okay. Even if open loop system is stable, closed loop can be unstable. If open loop is unstable, closed loop can also be stable. Okay. So directly just if the open loop system is stable or unstable, you can't talk about the closed loop stability. Okay. गजेंद्र, अगर ओरिजिन पे जीरो है मेरे भाई तो ओरिजिन डालने पे आपकी वैल्यू जीरो आ गई. We don't have any problem with zeros at origin. We have problem with poles at origin. Why? Because we can't substitute them into the function. Whenever we are plotting the Nyquist plot, what we are doing? We are putting every point of the Nyquist contour into GSHS and then obtaining the Nyquist plot. But if you are putting a pole, then it will blow up to infinity. But if you are putting a zero, then it will just become zero. It will just become zero. So we don't have any problem with zeros on imaginary axis or zeros on origin. But we do have a problem with poles lying there. Now see. Now the polar diagram of a conditionally stable system for open loop gain k equal to 1 is shown. Now the open loop transfer function is stable. That is P is 0. The closed loop system is stable for. Now listen, this graph exists for k equal to 1. Now, the magnitude Remember, if there is any transfer function like k into 1 minus s by 1 plus s, the magnitude of such a function will depend on k. The magnitude will be directly proportional to k. That is what I am saying. That is why my friend, if k is not equal to 1, all the magnitudes will be multiplied by k. Are you getting this point? If k is not equal to 1, all the magnitude will be multiplied by k. All will be multiplied by k. Okay. Now, what we have to see is that for stability of closed loop system, -1 should not be enclosed. Correct? -1 should not be enclosed. So that means -1 can lie here. -1 can lie here. That is the first case. Are you getting my point? -1 can lie here. If -1 lies here, it is enclosed. If -1 lies here, it is not enclosed. Okay. If -1 lies here, then my dear, it is enclosed. What you have to check, just walk along the Nyquist plot. Imagine yourself walking along this curve. Then check whether -1 point lies to your right hand side or to your left hand side. This point, the last part is like I am walking like this. So it is lying to my right hand side. Okay. So it is lying to my right hand side. Here it is lying to my left. It is lying to my left. Here to the right, and this one is to the left. So there are two cases in which I am interested. First case is this one and the second is this one. So first case is -1 is less than -8k. So you can say k less than 1 by 8. First case. The second one, that -1 lies between -2k and it lies between -0.2k. If you multiply by minus, the inequalities will be reversed. Okay. So that means, my dear, this k will be less than 5 and k will be greater than 0.5. Okay. So 0.5 up to 5, B. The answer will be B. Either use this condition, you get 0.5 up to 5, or using this you get less than 1 by 8. Less than 1 by 8. For such type of questions, remembering the criteria of stability using the polar plot is very, very necessary, because here you can't draw the Nyquist plot. Unless you know the transfer function, you can't draw the Nyquist plot and determine the stability. And my dear, if you have the transfer function, why to apply even the Nyquist criteria? Directly go for Routh criteria. Routh criteria will directly give you answer. But remember, whenever polar plot is given and it is talking about stability, you have to understand the stability criteria using polar plot. Vamshi, my dear, in the option it is asking the range of k for stability. The graph is given for k equal to 1. So unless you introduce k, how can you judge the range of k for stability? You can't judge it unless you introduce the value of k. So what I have said is, k always appears in the numerator of the transfer function. That means any magnitude that you find will directly be proportional to the k. No, Siddharth, we cannot determine transfer function using Nyquist plot. Okay, next question. Draw the Nyquist plot. Draw the Nyquist plot. I am giving you 120 seconds for this. I am giving you 120 seconds for this. Try this. The timer is running, my dear. The timer is running. You have 120 seconds for this. Let me see how many people can crack this question. I have some very good questions today lined up for you, but you have to be very quick in attempting everything so that I can teach you many concepts through these questions. I believe now the determination of stability using the polar plot is clear to each and everybody, because that is one of the concept that is not very trivial. Okay. बालाजी माय फ्रेंड, ये वाला जो क्लास है शाम वाली, ये चलती है इंग्लिश में, और सुबह में जितने लेक्चर लगते हैं दैट इज ऑलवेज इन हिंदी. ठीक है. मॉर्निंग बैच इज द सक्षम बैच, दैट इज इन हिंदी. इवनिंग बैच इज द टेस्ला बैच, दैट इज इन इंग्लिश. ओके. So some subjects we conduct in English, some in Hindi, to cater to both type of students. Okay, but the English is very simple. I believe the Hindi speaking students are at a good advantage because they can understand English as well as they can understand Hindi. Swagat is asking how 5 and minus 0.5 came. Swagat, my dear, try and solve the inequality. Okay, try and solve the inequality. You will understand how 0.5 and minus 0.5 came. Balaji, मेरे भाई, morning में EDC is running. Okay, in the morning we are conducting instrumentation, and in the morning we are also conducting signals and system. Okay, okay, now it's over. Let us see. First of all, let me draw the Nyquist contour that we draw every time. Gajendra, my dear, only 2 subjects are remaining on this channel, measurement and analog, so please try and be a bit patient. Don't ask for everything. Okay, everything will come with time. Already so many subjects are running, and we are taking care of IN students as well. Not only electrical ECE, but IN also. Now, we will divide the curve into 4 parts. One, two, three, 4. Okay. Now, first let me take 1. It is S equal to J omega. S equal to J omega. That means, my dear, we talk about the polar plot. Now, this is a type 2 system. So that means the tail is at minus 180 degree. And it is a order 4 system. That means head is at minus 360 degree. Very simple. This type of polar plot I have covered in the class. Second, theta is 90 to minus 90. Okay, 90 to minus 90 r e to the power j theta. Now, Okay. Now, when r is much higher than 1, then you can ignore 1 in front of it. If theta goes from 90 to minus 90, this is a circle of radius tending to 0 and angle minus 360 to 360. That is 720. 720, that is 2 times. That is 2 times. Okay, 2 circles. Then the third one, my dear, is S equal to minus j omega. That is very simple. Inverse polar plot. And the fourth one, S is limiting r tending to 0, where theta goes from minus 90 to 90. Minus 90 to 90. Now, what is GSHS? Okay. Now when r is tending to 0, you can ignore r in front of 1. So this radius tends to infinity, and my dear, minus 2 theta will go from 180 to minus 180. That is one circle. Okay, one circle. Now, how does this plot look like? How does this plot look like? Okay. So the plot starts, the tail is at minus 180, the tail is at minus 180, and the head is at minus 360. Head is at minus 360. आयुषी, पोलर और नाइक्विस्ट में किस बात का कंफ्यूजन है? नाइक्विस्ट का एक पार्ट होता है पोलर प्लॉट, बस इसमें कंफ्यूजन कैसा है? टेल इज एट minus 180 and head is at minus 360. Now, how to do it? Minus 360 means this. 1 minute. It will go like this. And then this is a circle which goes from minus 360 to plus 360. It is going like this. So minus 360 to plus 360. So this is 2 times circle. Then we will get the inverse polar plot. Then we get a infinite circle. Then we get a infinite circle like this. This will be your Nyquist plot. Okay, this will be your Nyquist plot. Is that clear? This plot is clear to everybody. Now, what I am going to do, as you were asking me again and again, sir, what happens if zeros are added? Look, I have added the zero. Now try this. I have added zeros to the same function. Now again you have to draw it. Again you have to draw it. This is addition of zeros. Okay. Now you have 150 seconds. 150 seconds. Gayatri, we just have to draw in the flow the infinitesimal semicircle that you are drawing, the circle of zero radius. Try and draw it with the flow. Okay, directly with the flow, the curve is going like this, so it will go and come out like this. Okay. Gajendra, if you want to check whether it starts from above or below the real axis, for that you have to check the intersection with the real axis. Okay. Pulkit, I'll show you why it is intersecting. Don't worry. Just let me come to that. I am coming to that. Okay. Why it is intersecting with the imaginary real axis, that we'll see. Okay. Let me just clear that query. People are asking me, how can I say it is intersecting? So let me tell you one concept. Let me tell you one concept. Intersection with real axis. Okay. So now, in this what you have to do, my dear, when you form GH j omega, let me tell you, j omega square 1 plus 2j omega. So here we figure out the value of phi. Okay. Now, when negative real axis you want, negative real axis intersection, for that, my dear, you will keep phi equal to minus 180. Okay. So from here you get tan inverse omega. This is 0. So you get only 1 root omega equal to 0. So that means, my dear, that means, let me rub this, let me draw this again. So let me draw it again. This time so here we have shown that it does not intersect the negative real axis for any value of omega. So see clearly, it is going like this. Okay. Now you were talking to me about the infinitesimal circle. Okay. So here we are getting from minus 360 to 360, that is 2 circles. So just take 2 circles about origin, one circle, the second circle. And then, my dear, this is your second point. Now here we will get a infinite circle like this. Okay. So this is your polar plot. This is your inverse polar plot. Okay. See now, it is very simple, yaar. It is very, very simple. Just we have to draw like this. Now you were talking to me about clockwise or anti-clockwise. If this was clockwise, this had to be anti-clockwise. Just wait a bit. Let me draw it anti-clockwise. Minus angle will make it anti-clockwise. So anti-clockwise, how we can go? This is clockwise. Okay. This was a query of many students that this must be anti-clockwise, right? This should be anti-clockwise. Okay, why anti-clockwise? Let me tell you. See, this was clockwise 90 to minus 90. This was clockwise. Now this is minus sign. That will make it anti-clockwise. Anti-clockwise. So try and draw two anti-clockwise circle here. Just two anti-clockwise circle. This small circle will be there. Now see, what is the value of n? 2 times anti-clockwise, 1 times clockwise. It is minus 1. It is minus 1. And even, my dear, in the last lecture, someone was raising one objection. Okay. This is based on last lecture, that is 62, type 1, order 3. If you watch lecture number 62, there we had for small circle we were getting, and this also should be anti-clockwise. Someone correctly pointed it out. So how was this? Just a minute. For type 1, order 3, it is like this. So we need anti-clockwise semicircle. One circle, one semicircle. And then, my dear, this can be like this. Okay, this can go like this. And then we can have like this. Okay, are you getting my point? So this is going in the anti-clockwise direction. Okay, this is going in the anti-clockwise direction, in the anti-clockwise circle, then one semicircle, then we have the inverse polar plot. So just remember the direction. Now let us come to this. I have added some zeros to the function. So Nyquist contour is same. I am not drawing the Nyquist contour again. So I am directly starting with 1. S equal to j omega polar plot. So my dear, the tail depends on the type of the system. But the head will depend on all poles and zeros. So there are 4 poles and there is 1 0 minus 270. Otherwise, my dear, I can also write it. Let me show you why I am saying this. Why I am saying this, let me show you. Okay. This is the value of the transfer function. Okay. This is the value of the transfer function. Now phi. Tan inverse 4 omega minus 180 minus tan inverse 2 omega minus tan inverse 2 omega. Now my dear, at omega equal to 0, the phase will come out to be minus 180, and as omega tending to infinity, you can see that the phase will be 90 minus 180 minus 90 minus 90. So that is what I wrote earlier also. Now, if you want, Aja, tell me one thing now is clear. How to draw the small circle? Now is it clear to everybody? How to draw the small circle? Yes, in the last problem, 3 semicircle guna Sekhar or 1 circle plus 1 semicircle. So to find intersection with the real axis, you will keep phase equal to minus 180. So minus 180 will get cancelled from both sides. Okay. This gets cancelled. Tan inverse 3 omega. Now, when you equate both the things, so you get one solution as omega equal to 0. But what about the other one? If you cross multiply, you get 1 minus 2 omega square is 3 by 4. 2 omega square is 1 by 4. Omega square is 1 by 8, or omega is 1 by 2 root 2. So that is a finite value. That means now, my dear, it intersects with negative real axis. Okay. The second part of the Nyquist contour is S equal to limiting okay. In most of the cases, you can ignore even the second part. But why I have taught you the second part? Is because that will give you an insight on how to exactly draw the Nyquist plot or the polar plot. Okay. So if you put it, and if anybody is not able to understand, please watch the video again. You will come to understand. Okay. Please watch this lecture and the last lecture again. That will broaden your understanding. Now, my dear, when R is so high, you can ignore 1 in front of R. And you will get 1 R e to the power j theta will cancel the denominator. You will get this. Okay, that is the radius of such a curve tends to infinity, and this minus 3 theta, that will go from minus 270 to 270. Okay, that means 3 anti-clockwise semicircle. Okay, this one is clockwise. With minus theta, it will become anti-clockwise. When there are zeros involved in the function, it is better to check the intersection. Okay. We will have inverse polar plot. Now, the fourth part. R e to the power j theta. Okay, and guys, tomorrow I think again we have a DPP session. So we'll see more problems and this concept will be cleared. Don't worry about it. Now when you put r tending to 0, you can ignore r in front of this. So that means radius tends to infinity. And this minus 2 theta. This theta here goes from minus 90 to 90. If you see the Nyquist contour. That means clockwise. Now see. Tomorrow we will have the last lecture based on the Nyquist and the polar plot, and day after tomorrow we are going to start the gain margin, phase margin. Okay. Now see, the head of the polar plot is at minus 270, tail is at minus 180. So tail is at minus 180. And head is at minus 270, like this. And it is intersecting at omega equal to 1 by 2 root 2. See, omega equal to 1 by 2 root 2, you will get an intersection with the negative real axis. Now we have 3 anti-clockwise semicircle. 3 anti-clockwise semicircle. So how? One circle, one semicircle, like this. Okay, then we will have the inverse polar plot like this. And then, my dear, we will have one infinite clockwise circle. Like this. Okay, like this we will have. Now here if you see one anti-clockwise and one clockwise encirclement, so the net value of n would be 0. One anti-clockwise and then one clockwise. So the net value of n, that is the encirclement of origin, is 0. Net value of n will be 0. Is that clear? So that is how the Nyquist plot looks like. Now, my dear, here you have to find do one thing for me, find intersection with negative. Now I think I must be audible, my dear friends. So you must be able to hear me. Okay. So guys, what I was saying is that if you want to become a part of our batches, then you have to download the Unacademy learning app. And other than that, what you have to do? You can buy the 12 month subscription, if you buy plus, 12 month subscription is at 2083 per month and 24 month subscription at 1250 per month. But use the code Ankit ESE. And if you buy 12 months iconic subscription where you get personal mentorship, it is 4500 per month if you apply the code Ankit ESE. Ankit ESE. And you get no cost EMI for subscription for 6 months, 12 months and 24 months. You can pay by credit debit card, EMI, net banking. Also you can pay by HDFC debit card EMI or Bajaj Finserv debit card EMI. But don't forget to use the code. And this is my Telegram channel where you will find all the PDF. And this is my Unacademy profile which you have to follow to watch all the free content. And don't forget to check out this link. To watch all my free classes. Okay. Now, you can subscribe to Electrical Junction channel to get all the electrical content. Here I will be teaching live. You can follow Telugu channel if you are a Telugu speaking student. You can follow GATE question if you want to watch video solution of previous year. Engineering Pathshala, learning engineering through animation. Foundation for your basics. Computer science for your CS friends. This is for your mechanical friend. This is for your civil. Now, if you are preparing for JEE and AE exam, do subscribe to Unacademy SSC JEE. And at last, I would like to thank you all for giving your valuable time and attending this session. And I believe we'll meet tomorrow again at 7 p.m. and we'll learn a lot of awesome concept about Nyquist plot. So Nyquist plot is officially over. Now we'll see questions tomorrow. Okay. So that is all from my side. See you at the same time tomorrow. Thank you.